Hello everyone, welcome to the video lecture on Industrial Electronics. Our subject code 15A04606. This is for the BTech third year second sem students, those who are studying under JNTU Anantapur under regulations R15. I am Dr. A. Karthikeyan, working as a professor in the Department of ECE, Viswodaya Engineering College, Kavali, Andhra Pradesh. In this unit 1, we are going to discuss about the following topics. That is, the topics which are covered in the syllabus are scope of industrial electronics, semiconductors, and the merits of semiconductors. Then about the crystalline structure. Crystalline structure means what is the structure of that the materials, semiconductor materials which are used in that intrinsic and extrinsic semiconductors. And then the current flow in semiconductor, then open circuited PN junction, diode resistance, then about that special semiconductor device, xenodiode, photoconductors and junction photodiodes, along with the photovoltaic effect and lighting emitting diodes, that is the LED. These are the topics which we are going to discuss in that unit 1. Now we can, before going to start with the syllabus, now we can see some small introduction about what is electronics and what are electronic devices. Electronics is nothing but it is a branch of engineering and it deals the current conduction through a semiconductor. If you take electronics, why it is named as electronics means that is it discusses with that the electrons which are present in all the materials, and also it deals with the electronic devices and their utilization. Now what is electronic device? A device in which if the current is flows through a semiconductor, then the devices are called as electronic devices. These electronics and electronic devices has a much importance in industries and various applications throughout the world. It has a much importance due to its numerous applications in industries, and these electronic devices are capable of performing the following functions. Now we are going to see here a few functions which can cover the entire capabilities of electronic devices. Number 1, rectification. Do you know what is rectification? Rectification is nothing but the process of converting AC into DC. As you all know very well, in our domestic applications, we are using AC supply. Someone uses a single phase AC supply and someone may use 3-phase AC supply. But whatever it may be, it is an AC supply. If we take it is a single phase AC supply, then it is 230 volt is a voltage which is available at the domestic applications with the 58 AC supply. But if you see that television, the devices, electronic devices or the electronic appliances like a television, CD player, and if you take a tape recorder, or if you take a personal computer, then that are all works with DC supply. But in our domestic applications, the available one is AC. Then suddenly we are in need to convert that AC into DC. For that, we are in need of a rectifiers. That is, that rectifier can be designed with the help of this electronic devices. And this one is converts. This rectifier is converts AC into DC with very high efficiency if you use the electronic devices. And what are the major uses of the DC supply means? Here only listed a few things because it has unlimited usages, because here you have mentioned only a few things. That is, if you want to store, that is, if you want to charge the storage batteries, then we are in need of a DC supplies. You know well, we can't able to store that AC supply. So only the thing is, even if you use the inverter or UPS in your home, that is, we have to convert this AC into DC, and then that DC supply should be stored in the batteries. After that, once again, if you want to get back that AC supply, then that DC supply which is stored in the battery is converted with the help of an inverter. That's why that is named as an inverter. Inverter means it is the opposite to that rectifier. Rectifier means it converts AC into DC. Inverter means it converts DC into AC. So that stored charge is always
DC supply. So to charge that storage batteries, we are in need of a DC supply. Like that, if you take a DC generators, then suddenly to excite that DC generator, we are in need of a field supply. That field supply is possible with the help of this DC. That is a AC into DC, and after that, with the help of a DC, we can supply a field winding of DC generators. Then the electroplating, that is, it may be studied this one in our chemistry. For that electroplating, that is, if you want to coat any other colors in the plate, then we have to go for this method, electroplating. Here also we are using a DC supply. Next one is amplification. What is amplification? Actually, it's the process of increasing the strength of weak signal. What is the necessity to increase the strength of the weak signal? Say, for example, if you take a radio, then radio sets are used to receive that atmospheric signal, that is the signal which are available in that atmosphere, and we are going to convert that into an audio signal. So the signal which is received through an antenna are a very weak signals. Then if you want to hear that one is an hearable audio, that is a audible signal, then certainly we have to convert that weak signal into a stronger one. Okay, so in that case we are in need of an amplifier, that is the electronic devices which accomplishes this amplification process are called as amplifiers. So with the help of amplifier, we can convert that is a weak signal into and strengthen, that is a strong signal. That is it is very easy. So these are used in the variety of ways. Say we can see only the few examples here. That is a radio set to amplify the weak signal to a stronger one so as to hear loudly. Then PA systems. Have you heard this word PA system? Public addressing system. That's nothing but which is used in that festivals or in any other functions. We can see a bulk box will be there in front of nearer to that mic. That one is through a mic. It receives this PA system receives that audio signal, and it amplifies that signal into a louder one. And the television set. Even if you see the television, if we are increasing that volume, that is how it is possible. How we are increasing that volume? It is possible with the help of an amplifiers. This one are made up of, that is these amplifiers are made up of electronic devices. The next one is that control applications. What are control applications? If you take this electronic devices are the wide applications in automatic control industries. When you think automatic control systems, that is if any devices controls means if this output quantity is controlled by varying the input quantity, it is a controlled one. Automatic means if it is the process is made automatic one without any manual intervention. If it is if we can possible to control that output, then it is called as an automatic control system. In that, this electronic devices takes a major role. That is say for example, speed of a DC motor. If you want to control a speed of a DC motor according to a function or according to that the requirements, then we can use this electronic devices so as to design a control system so as to control the speed of DC motor. Like that, if you take a refrigerator, depending upon that the coolings which is required, we have to change that. That is, we have to control the refrigerator cooling systems. That is possible automatically with the help of such electronic devices. The next one is generation. If you take a generation means here how we can able to generate the different kinds of signals. That means that is our domestic applications. We are using a 230 volt AC supply. That supply is of a sinusoidal signal. But in electronics industries, we are in need to use various kinds of signals like a sine wave, square wave, triangular wave, or pulses like that. That is, with the help of these electronic devices, we can able to convert the DC power into AC power of any frequency. By this way, we can generate different kinds of signals. That is by converting a DC power into AC power at any frequencies. So that are all called as an oscillators. Here that named as oscillators here. These oscillators has a wide variety of uses that are all, say for example, electronic high frequency heating is used for annealing and hardening purposes. Okay, that is if you suppose if you want to take an electronic oven, that is electric oven, then there also we are using that high frequency heating method. That is also that is possible with the help of this oscillators. The next, conversion of light into electricity. That is if you want to convert that light energy into that electricity, it is very known. These devices are called as a photoelectricity. That is a photoelectricity principle. It functions, and this conversion of light into electricity is known as a photoelectricity. These photoelectric devices are used in the burglar alarms and the sound recording on motion pictures. That is, if you want to record a sound whenever a motion is detected in the pictures, that is in videos, then we can use this kind of devices, photoelectric devices. And the conversion of electricity into light. If you want to convert, that is a reverse back. That is if you want to convert this electricity into light, it's well-known devices. That is there are so many devices are there in electronic. That is it converts that electricity into light, and its properties are utilized in the television and radar systems. That is the supplied electrical energy is converted into that light energy, so as to it can be shown like a image in a television.
Scope of industrial electronics. That is, what is the scope of industrial electronics? It is defined as a science. This is nothing but basically a science that deals with the electronic devices which are used in systems, that is, which are useful in industrial applications. So we can say scope of industrial electronics is nothing but it is defined as a science that deals with the electronic devices used in systems which are useful in industrial applications. So now we can go for that. What is industrial electronics? This one includes a study of semiconductor devices. We are going to study about the semiconductor devices and the electron tubes, transducers, as well study of electrical circuits which are used in that. This is the scope of industrial electronics.
Can be shown like a image in a television. Now we can see the properties of an electron. This electrons has various properties. Now we can see that it may be discussed this one in that previous semester, but even though you can take some small intro about that, what are that nucleus, electrons, protons, everything. Here, if you take an carbon atom, then it's a center part, that is the innermost part is called as a nucleus. This nucleus contains a proton and neutron, and these electrons are available in that its outer orbits. It has that many number of outer orbits. If you take this one is the center part, it's a nucleus, and that electrons are available in that outer orbits. That electron in that first orbit has that lowest energy. That is, since that electrons are, it is tightly coupled with that nucleus, it can't be able to move this. It can't be able to move away from this nucleus because of it has that lowest energy. That means it is tightly bonded or connected with that nucleus. Then when you go for this second orbit like that, when we move on to that outermost orbit, that outermost orbit has certain electrons. That electrons gains a highest energy when it moves away from this nucleus. So that is these electrons. The electrons which are present in that outermost orbit are gains at highest energy levels. That is energy level is increases as this distance from the nucleus increases. Some properties of an electron. This is a charge of electron is 1.602 into 10 power minus 19 coulomb, and the mass is 9.1 into 10 power minus 31 kilogram. Its radius of electron is 1.9 into 10 power minus 15 meters. The electrons which are present in this outermost orbit are known as valence electrons. Note this, the electrons which are available in that outermost orbit are known as valence electrons. Actually, these valence electrons are that loosely attached to the nucleus, hence that are all known as free electrons. since these valence electrons are loosely attached or coupled with that nucleus. That's why it is called as a free electron, because it has that high energy, so it can able to move anywhere here. Then now we can go for this energy bands. In case of a single, if you take a single, if you assume single isolated atom, then that electrons in any orbit possesses some definite energy. Some definite energy when we take it from orbit to one orbit to another orbit, it takes some definite energy. But in case of a solid, that all the atoms, that is the one atom is coupled with that another atom. Like that, all the atoms are closely packed with that nearby atoms. As a result of this, these electrons which are present in that any orbit have such atoms as a range of energies. Rather than a single energy, it gains a range of, it possesses range of energy. So such range of energies can be mentioned or can be shown in the form of a energy band diagram. That is called as energy band. Band means here it is an energy acquired by the electrons in each and every orbits. Here, importance of energy bands in solids. That is to know about the importance of energy bands in solids, we have to discuss about the three energy levels. That is the energy band levels. That is our valence band, conduction band, and forbidden energy gap. That is the electrons. The energy of electrons can be mentioned here with the help of this valence band, conduction band, and forbidden energy gap. That is this is called as a energy band diagram. And that this one is called as a conduction band, and this one is valence band. The gap between this conduction band and valence band is called as a forbidden energy gap. This is in y-axis. It is a band energy. First of all, what is a valence band? The range of energies is called band. That is the range of energies possessed by that valence electrons. The energy acquired or possessed by that valence electron is known as valence band. The electrons in the outermost orbit of an atom are known as valence electrons. Already we have discussed this one. The electrons which are present in the outermost orbit are known as valence electrons. In normal atom, this valence band has electrons of highest energy. These electrons which are present in this valence band or acquires the highest energy levels. And this band may be completely or partially filled one. This band may be completely or partially filled one. Say for example, if you take an inert gas, in that the valence band is full, whereas in other materials it is only partially filled. Here we have to note one thing. If it is a partially filled one, it can able to accommodate more number of electrons. It means it is partially filled one. If it is fully filled means, it is completely filled means it can't able to accommodate more number of, that is any more electrons. Since it is a partially filled one, it can able to accommodate more number of electrons. The next one is conduction band. In certain materials, say for example, if you take a metal, these valence electrons are loosely attached to the nucleus. In the metal, these valence electrons are very loosely attached with the nucleus. As a result, that is if you take an ordinary temperature, that is a room temperature, then some of these electrons may get detached from that nucleus and it becomes a free electrons. Normal room temperature, this free electron, that is these valence electrons is detached from that nucleus and it becomes a free electrons. Actually, these free electrons are the responsible one for conduction of current in a conductor. That is the reason why this is called as a conduction electrons. The electrons which are present in this conduction band are called as a conduction electrons or free electrons. The range of energy possessed by this conduction band electrons are known as conduction band. That all the electrons in the conduction band are free electrons. Note this one. All the electrons which are present in this conduction band are free electrons. Here we have to note, if you take a substance, then that has that empty conduction band. If you take any substance, a certain substance, if you find a conduction band is empty one, then that means there is no possibility of current conduction in that substance because the current conduction is empty. Say example, it is an insulator. If you take that substance is an insulator, in that you can find the conduction band is empty one. Suppose in case of a conductor, conductor is a purely conducting materials that are called as a conductors. It is partially filled one. That means it can able to accommodate more number of electrons. The next one is the forbidden energy gap. What is a forbidden energy gap? The space, there is a separation between that conduction band and valence band. That energy gap or the gap between valence band and conduction band are known as forbidden energy gap. Here we have to note there is no allowed energy state in this region. That is because that electrons does not gain any energy levels in that gap. That is in the space between that and the conduction band and valence band. So this width is called as the width of this forbidden energy gap is a measure of bondage of valence electrons to the atom. That is by measuring the forbidden energy gap. Usually this one forbidden energy gap is measured in terms of electron volt. Based on the energy gap, we can say how closely or how tightly that valence electrons are bonded or coupled with the nucleus. If you find the energy gap is greater one, that is it's very high, then it means that electron, that valence electrons is more tightly, it is tightly bonded with the nucleus. So in that case, if you want to push that electrons from that valence band to the conduction band, then we have to supply certain external energy. How much? That is that has to overcome the forbidden energy gap. That much of external energy must be supplied so as to make that one as a valence electrons as free. That is to make this valence electrons as free electrons, then we have to supply external energy. So if by supplying external energy, we can able to push this electrons from the valence band to the conduction band. The classification of solids and its energy band. Now we can see some solids and we can see that the energy band levels in that solids. Here we are going to take three solids. One is the insulator, another one is a conductor, and third one is a semiconductor. Now we can start with that insulators. Insulators are that purely non-conducting material. Examples: wood, glass, paper. These are all that examples for this insulators. That is, it does not allow that passage of electric current. Okay. Say this one is that energy band diagram of insulator. See, look at here. It is that energy gap. It is measured in terms of electron volts. It is energy gap is here. It is a 15 electron volts. It's very high. In an energy band, that is a energy band diagram. That is the valence band is full, and here the conduction band is empty. Here there is the energy level of the conduction band. It is the energy level of valence band. So here the energy gap between both the valence band and conduction band is very large. There is a huge one, that is of 15 electron volt. So because of this high energy gap, that is a the greater energy gap between this conduction band and valence band, a very high electric field is required so as to push that electrons from that valence band to the conduction band. We are in need of a very high electric field. At room temperature, this valence electrons of the insulators does not have sufficient energy to cross over to the conduction band, from the valence band to the conduction band. When this temperature is raised, when this insulator is subjected to a temperature which is greater than the room temperature, then some of these electrons which are present in this valence band acquires sufficient energy so that it crosses over to the conduction band. So here the resistance of that insulator decreases with increase in temperature. From this you can know one thing: when this resistance decreases, the temperature increases, and this property is called as a negative temperature coefficient of resistance of that particular material. here that insulator has that negative temperature coefficient of resistance because its resistance decreases when the temperature increases. The next one is the conductors. Conductors are those substances which easily allows the passage of electric current through them. That is, it's a purely conducting materials are called as a conductors. We can able to pass this electric current through them easily. There is examples of copper and aluminum. These are all the pure conductors. Because of this, there are a large number of free electrons which are available in these materials. It can able to easily pass this electric current through them. Just look at this energy band diagram. Here, both this conduction band and valence band are overlap each other. That means there is no energy gap between a conduction band and valence band. So due to this overlapping, a very little bit amount of potential differences more than enough to cause a free electron, to cause electrons to move from valence band to conduction band. That is to cause the free electrons, so as to constitute an electric current. So it's clear that there is no energy gap since both the conduction band and valence band are overlapped each other in case of a conductors. Let me take a next one is the semiconductors. If we take a semiconductor, in this that electrical conductivity, that is the conductivity, the conduction through a semiconductor lies between a conductor and insulator. That is the energy gap in the case of semiconductors is not too much high like an insulator, or not overlap like a conductor, but it lies in between conductors and insulators. So here it is the electron volt, that is the energy gap is measured in terms of electron volt. Here it is a 1.1 electron volt is the energy gap between a conduction band and valence band. Say if you take some materials like germanium and silicon, these are all the semiconducting materials. In that, the conduction band is almost empty and that valence band is filled with of free electrons, that is the valence electrons. Here it's filled with of valence electrons, and at the same time here the conduction band is empty here. Since it's when the energy gap between this conduction and valence band is very small, we are in need of a very small electric field which is greater than that. The electric field which is applied to the semiconductors, somewhat it is greater than the conductors, and when that smaller electric field is applied, that electric field applied is less than that insulator, but at the same time it is greater than the conductors, then it pushes that the valence electrons to from the valence band to that conduction band, and it makes it a free electron, so that it constitutes a current. At that low temperature, this valence band is completely full and the conduction band is completely empty. Therefore, this one acts as an insulator at the low temperature. At that room temperature, some of these electrons, say they take 1 electron for 1010 atoms. Some electron means here 1 electron for 1010 atoms or cross over to the conduction band, and it impacts that a little conductivity to the semiconductors. That is at room temperature. That is when temperature is increases, automatically the current conduction is increases here. As this temperature is increases further, then the more number of free electrons which are present in that valence electrons which are present in that valence band or tries to cross over to the conduction band, and so that it increases the conductivity. So it's clear that the conductivity of the temperature is semiconductors increases with the increase in temperature. So this semiconducting materials are also as a negative temperature coefficient of resistance. Let me see what are that semiconductor. Actually, semiconductor is a substance. It has the resistivity of 10 to the power minus 4 to 0.5 ohm meter. That is this resistivity lies between a conductor and insulator. This resistivity is less than an insulator, but at the same time it is greater than the conductor. Example for this semiconductors are germanium, silicon, selenium, carbon. These are all the few examples of semiconductor. There are a few properties of a semiconductor. The resistivity of a semiconductor is less than that insulator, but at the same time it is greater than conductor. And the semiconductors have negative temperature coefficient of resistance. As we discussed, resistance decreases with the increase in temperature and vice versa. Examples are germanium. Germanium acts as an insulator at low temperature, and at the same time it acts as a good conductor at high temperature. When a suitable metallic impurities, when impurity is added to a semiconductor like arsenic, gallium, etc., then we can improve the current conducting properties of the semiconducting materials of germanium and silicon. That is the current conducting properties of this germanium, silicon materials, that is the semiconducting materials, can be changed with the help of adding impurities on it. Commonly used semiconductors are germanium and silicon. The reason behind this one is the energy required to break the covalent bond, break the covalent bonds of both germanium and silicon is very small, because to release that electrons from that valence band, we are in need of a very small energy. Say example, 0.7 electron volt is the energy required in case of a germanium, and 1.1 electron volt is that energy required in case of an silicon. Classification of semiconductors. The semiconductors can be classified into intrinsic semiconductor and extrinsic semiconductor.